talking about using video ODS and specifically cell phones is making sure that we set you up for the maximum amount of success based on the setup of your phone. So today specifically we're going to talk about using an iPhone, at least controlling the parameters within the iPhone, but also just kind of the essentials, things to know, how long the video needs to be, the frame rate that you should use, and the differences between those, and that type of thing. But with that, let's get into it. First thing we talk about, and again, I talk about specifically with iPhones, but within the iPhone, you have these video options on here. There's a video tab. If you pull down from the top of the screen, or you go specifically to your camera, you can slide over to video and slow-mo, and those would be the two that you're using. But once you get to video up in the right-hand corner, you can kind of touch the options there. It'll change it. So specifically on the video tab, you'll have your regular HD, and that'll allow you to record in either 30 or 60 frames per second. And then there's a 4K option, and we'll talk about the benefit of that. But within the 4K option, there's 24, 30, and 60 frames per second options. And those are all, again, you just kind of touch in the corner. And I'll show it here in the video. I'll run the video in just a second. Then if you slide over again further, there's a slow-mo tab, and that allows you to have the options of 120 and 240 frames per second. Those are in HD. They don't have a 4K option currently with the higher frame rates, but we'll talk about the benefits of those also. But let me click this video. It should run here, and you kind of just see, you kind of touch up in the corner, changes it there again, that HD between HD and 4K, and then the frame rates. And again, very simple functionality, but some people don't know where those things are in the phone, so we like to have that there just to show you in that setup. Okay, so some things to consider here. Obviously, we talked about HD versus 4K in the phone, and then frames per second considerations. If you're looking at HD versus 4K, obviously HD is 1920 by 1080, and 4K is 3840 by 2160. So double the number of pixels in each direction. Obviously, it works out to 4 times the number of pixels total for 4K. It's glaringly apparent when you look at video side by side between the HD and the 4K options that 4K is considerably sharper. What that leads to, obviously, more pixels allows for better variation or better identification of motion within the video, higher level of accuracy. It's not 4 times more accurate by any means, but if you have the chance to use it where you only need 60 FPS, and you can get away with that, and you're doing lower frequency analysis, it's the better option for sure, just because of the increased resolution. Now, what is the frames per second, and how does it affect this whole thing, and like the frequency span that you can get out of this? Obviously, you're doing 30 frames per second, you kind of have a max span of 900 RPMs, 60 would be 1800, all the way up to 240 frames per second, which is the max in an iPhone currently. And that'll get you 7,200 RPMs, or if you're measuring in hertz, obviously 120 hertz. But that's what you're looking at for the max in that. Now, we talked about it in previous webinars. We won't get a chance to go over it today, but we do have a feature for rotating and reciprocating machinery that you can use, where it unaliases the data. So essentially what you do is you would identify the running speed of the machine. Let's say that you're running something at 1,000 RPMs. You'd identify that peak at 1,000, and what it's going to do is it's going to unwrap the data. So little complicated math in there, but it's going to unwrap the data so you can double your usable span. So if you had 1,000 RPM machine and you had 60 frames per second in 4K, you're going to get that 1,000. Then you're going to also get another 2 peaks out of it, because that 1,800 RPM that you would normally only see the running speed in, and the other peaks would alias themselves back. Now you're going to get 3,600 RPM, so you're going to get the first, second, and third orders on a clear line. But again, that's in a different webinar, and if you have questions about that, we can talk about that. You can send us a message. Okay, so for resolution, we're going to talk about how long the video should be and the considerations to go in that. Really what it comes into is the longer the video you have, the better resolution you're going to get as far as RPMs or hertz. If you take a 10-second video, and you can crop this after the fact, you can crop it in MEscope down to 10 seconds. however you want. I'd always recommend going a little bit longer, especially if you're going to start and stop the video with your finger. But simple considerations here: if you have a 10-second video, your resolution is going to be 6 RPMs or a tenth of a hertz. We have it here: 15 seconds would give you 4.5 RPMs, 20 seconds would be 3 RPMs, and 0.05 of a hertz resolution. So obviously, the longer the video, better resolution. Take longer videos. You can do spectrum averaging, a lot of things that can clean the video up considerably. It just takes longer processing time and longer video acquisition, and then obviously the video is larger. But definitely benefits to it, and especially depending on your needs for resolution, you may have to go longer. General setup as far as when you're going to take your video. Really, what we want to do is we want to maximize whatever structure you're videoing. We want to maximize it in the viewing window there on the phone. You don't want a whole bunch of background space and small. We just want to maximize the pixels that we have on the actual measured part. And in some circumstances, you may even just look at a certain area of a structure. So you just want to maximize that in the window. One thing we would recommend is using a tripod. They're kind of these simple spring-loaded mounts that go on there. Lightweight, you can get them on Amazon for cheap. I think they're $20 or something like that. But simple, obviously stable, so you don't have any motion from your hand or anything else that contributes to motion in the video. But a great option to use, one that I would highly recommend. Some other options, they have Bluetooth remote controls that you can start and stop your video with. It's a good option if you don't want any touch. I don't use one typically when I do my measurements, but again, I'll start it. I'm looking for 10 seconds of video. I'll start it with my finger. It stabilizes based on the tripod. I'll let it run for 15 seconds. I'll stop it again with my finger, and then I'll crop it down on the beginning and the end so I can take away any induced vibration from my start and stop. I'll clip that off the front and the back, and just use the stable video in the middle for my 10 seconds. So you don't necessarily need to use it, but if you want fully non-contact after you set it up, obviously they have Bluetooth remotes that you can utilize with your phone as well, and they're relatively inexpensive. You can get those through Amazon as well. So again, you can see in the video there, I started and stopped it just on the right-hand side, run it. It's stable here, aside from the camera that I'm filming the phone with, but we get the start and stop there, and just basically the way I was talking there, and you can clip down the video to your needs after the fact. Now, one of the things we talked about what's listed in iPhones as slow-mo video, and the reason why they listed as that is there's some functionality built into the iPhone where it's going to do almost like this smart capture in the middle of the video. And it'll slow the video down, the playback speed, so to take advantage of the higher frame rate, excuse me. The playback will slow down, and if you have an iPhone, you know how this works. We don't want that in there because ultimately what will happen is it'll screw the video up completely with the timing and accuracy and everything else. So we take that out of there by editing the video after the fact, after you've acquired it. And I'll show you here with this video, but we'll talk about it in here. So this is specifically for the slow-mo, 120 and 240 frame per second videos. And what we're going to do is we'll just be in our camera roll there, and we'll select the video, and then there's an edit button, and let me slide up here so I can see it. There's an edit button. It's like the 3 bars that are on the bottom. So you select that edit button, and then there's it'll show you, and we'll run this video so you can see, but it'll show you the section identified with the bar on the left and the bar on the right of the section that is doing the slow motion playback in the middle. What we're going to do is we're just going to take those 2 slider bars, we're going to pull them all the way to the right. That eliminates the slow motion functionality that iPhone automatically puts into the video, and then just gives us just the true unedited 120 and 240 frame per second videos. We'll save that, and then you can export it obviously into your computer or your laptop for use in MEscope, and we don't have anything with messed up timing or variable timing that's added as kind of like a cinematic feature for by Apple within the iPhone. Let me run this video here, and you can see what I'm talking about. So again, edit function on the bottom, You can see in the middle there where they have that slow-mo section, grab the bar, pull it all the way over to the right. Then we just go save it and we're done. Now you have unaltered video. So it's one of those things, it's one of the most common questions we get for people utilizing cell phones for ODS videos. But if you don't know that it's there, or you don't realize what it does, it can really screw up your results. So understanding how to take that out of there and just get your unaltered data there is very important.